Homework 7, question 8. So the question is saying the Poisson process is defined by the following three properties. The first, the number n t1, t2 of the point ti in the internal of t1, t2 of the length of t equals to t2 minus t1 is a Poisson random variable with the parameter lambda t. So probability of that n t1, t2 is equal to k is going to be equal to the e to the negative lambda t times lambda t to the k over k factorial. The second property is saying that if the internal t1, t2, and t3, t4 are not overlapping, then the random variable of n t1, t2, and n t3, t4 are independent. The third property will say at the time moment of t, no more Poisson point. So we form the stochastic process x of t is going to be equal to n of 0 and t. So A, try to find the expected value of x of t. So for probability of x equal to k equals to e to the negative lambda times the lambda to the k over k factorial. So we know that the sum of that e to the negative lambda times lambda k over k factorial is going to be equal to 1. So we put the e to the negative lambda to the right side of the equation. We get the and then we do the differentiate on both sides. So we know that the sum of that from k start from 0, that k times the lambda to the k minus 1 over k factorial is going to be equal to e to the lambda. So we know that the sum of the k times the lambda of k over k factorial is going to be equal to lambda times e to the lambda. So we know e of x is going to be equal to the sum of k times e to the negative lambda times lambda k over k factorial is going to be equal to lambda. So we know that e of the x of t is going to be equal to lambda times t. For the variance, it's going to be equal to e of x minus eta squared is going to be equal to e of x squared minus eta squared is going to be equal to e to the x squared minus lambda squared. So we know here the sum from k times lambda k over k factorial is going to be equal to lambda times e to the lambda, and then we do the differentiate on both sides. We get the sum of k times lambda to the k over k factorial is going to be equal to e to the lambda plus lambda times e to the lambda. So we know that the variance is going to be equal to expected value of x squared minus lambda squared, and it's going to be equal to 1 plus lambda times lambda minus lambda squared is going to be equal to lambda. And we also know that expected value of xt squared is going to be equal to 1 plus lambda t times lambda t. B, try to find the R of t1, t2. So the R of t1, t2 is going to be equal to expected value of xt1 times xt2. And then we do the simplify and plug in the numbers, so we get the expected value of xt1 times xt2 minus xt1 plus xt1. Then we do some simplification, then we get the lambda t1 times the lambda t2 minus lambda t1 plus 1 plus lambda t1 times lambda t1 is going to be equal to lambda times t1 plus lambda t1 t2. This is for the situation of t2 is bigger than t1. So for the t1 bigger than t2, it's very similar, and we get the answer for R of t1, t2 is going to be equal to the lambda of T2 plus lambda of T1, T2. So the R of T1, T2 is equal to lambda of the minimum of T1, T2 plus the lambda T1 times T2.